This is Algebra 2 with trig. We're working with Unit 2B.8. Polynomials and contexts. We're doing story problems. This first one is called a rectangular prism. And we know that the volume of this rectangular prism is 40 inches cubed. So we need to find out the value of x that's going to make this 40. And looking for an algebraic way to solve this, the one thing we know for sure is the volume is known as length times width times height. So our length, it really can be any of the dimensions. I'm going to call it the 2x because we like the 2x to be first, the monomial to be first. So we'll call this the length, call this side the width, and of course our height will be that one. So length times width times height. We know that the volume is 40, so we plug in our numbers. So we should all be able to get to this point. We need to make some decisions on what to do. So what would be a logical step to take?
Distribute the 2x into x minus 1.
We can distribute that in here. We could FOIL the parentheses together. At any means, we need to multiply this all together, whichever order you want to go in. That would totally work. You suggested to distribute, so we can do that. 2x squared minus 2x and now we have two binomials, so we need to FOIL. So we get 2x cubed. We get negative 8x squared. We get negative 2x squared. And we get positive 8x. So as we keep cleaning this up, we're going to get 2x cubed. Those two look like they become 10x squared. And this is 8x. So we would all probably multiply those together. Remember, we're trying to determine what x is. Stick with what you're trying to accomplish. So if we have this polynomial, it has multiple types of x's. We need the 40 to come to the other side. We need to make this equal 0. So we have 2x cubed minus 10x squared plus 8x minus 40. Now we're looking at this cubic equation. How do we go about solving this cubic equation for x? There's probably more than one way to do that. What would our suggestions be? We can try factor by grouping. So we're going to take our 2x cubed minus 10x squared plus 8x minus 40. That is equaling 0. So we're going to group those together. And when we do factor by grouping, we pull out the 2x squared. That leaves us with x minus 5. Bring down our sign. Now, out of this other group, you want to pull out your common factor, which is 8, which leaves you with x minus 5, and which is good, because we need, for factor by grouping to work, we need what's inside the parentheses to be the same. If they weren't the same, then you couldn't use factor by grouping. So we can write these as our two factors, 2x squared plus 8 and x minus 5. We don't say x minus 5 squared, we just say x minus 5. Now we have our two binomials that this equals 0. So we can use what's called the zero product property. That would be 2x squared plus 8 equals 0. When you subtract the 8 across and divide by 2, we get the number of -4, and we take the square root of that, so we get plus or minus 2i. What does that mean? That means that's two imaginary solutions. Not because of the 2, but because of the plus or minus. We have two imaginary solutions. In other words, that doesn't give us any answers. That's what that means. Maybe the x minus 5 gives us an answer. And as we add the 5 to the other side, we get x equals 5. And that's the variable value of x that we're going to use to plug in to figure out 40. 5 minus 1 is 4. 5 times 2 is 10. So 4 times 10 is 20. Did I say that wrong? 4 times 10 is 40. And 5 minus 4 is 1. So 40 times 1 is 40. Made my way through that. So x is 5. We answered the question. What value of x gives the volume of the box 40? And that would be x is 5. Our next question. We have a company's profit, which is going to stand for the variable p, and that p value is going to be multiplied by 1,000 because it's in thousands. So if your profit happens to be 28, it's going to be 28,000. So the p stands for thousands, and it can be modeled by this equation where x is the number of items that are produced, and that x value is going to be multiplied by 1,000. It's going to be represented in thousands. So if we get an answer of 7, it's going to be 7,000 items. The profit is 14,000, and we get that when we produce 2,000 items. So if you produce 2,000 items, you get a profit of 14,000. What other number of items would also produce the same profit? Think about how to do that. Pause the video, work on that problem, come back, we'll help you through it. So we have our profit, and that equals negative 5x cubed plus 6x squared plus 15x. So our profit is supposed to be in thousands, so that's why we're going to use the number 14, and we don't use 14,000. The profit in thousands, so we say 14 because that represents 14,000. Negative 5x cubed plus 6x squared plus 15x. There's a way to do this with your calculator, and we'll show you that. But first, we want to do this algebraically. So what it says here is that we get 14,000 when we have 2,000 items. When we produce 2,000 items. And remember, the number of items is in thousands, so we're just going to use the number 2. So if x equals 2, right, this is one way to do it. This is kind of direct substitution. We already know what the answer is going to be. So this is negative 5 times 8 plus 6 times 4 plus 30. That's negative 40 plus 24 plus 30. That's 54. Take away 40. That is 14. We knew it was 14. They told us it was going to be 14. That was the whole problem. They said when you use 2 or 2,000 items, you get 14 or 14,000. So yes, 2 works. We knew that. The question is, what else works? If we want to be totally random, we could try 1. We could try 2. Well, I guess 2 works. We could try 3 and 4 and 5 and 6. Should we try negative numbers? Should we do plus or minus 1? That's what we usually do. We're not producing negative numbers. So no, we're not going to produce a negative 1,000. So no, we don't do negative numbers. No need for that. So, if you would use synthetic, before we do synthetic, we're going to move the 5 over, the 6 over, and the 15 over. I don't want to move the, the 14 over, because I don't like a leading coefficient to be negative. So I'm going to add the 5x cubed over, subtract the 6x squared over, minus 15x. I already have a positive 14. Now that's 0 on that side. I brought them all over to the same side. Because of course that's what we need to do with a polynomial. We need to equal it to 0. We know that 2 is a 0. That's what they told us in the very beginning. So we're going to drop down our 5 and multiply to get 10. That gives us 4. Multiply to get 8, negative 7. Multiply negative 14, that gives us 0. Well, we knew that. We knew we would get 0. So x minus 2 is a factor. What else would be a factor? What else would produce a 0? So when we plugged in 2, it was like us dividing x minus 2 into this problem. We have a 0 remainder. So that means our 5 is actually can be written as 5x squared. Our 4 is a 4x, and our negative 7. We are 1 degree less than our x cubed, because we divided it by our x minus 2. Unfortunately, this is not factorable. When you look at 5 times negative 7, you get negative 35. That adds to be 4. So negative 1 and 35, negative 5 and 7. Those are the only factors to get to 35. So we can't solve this by factoring. So what's the other way we solve a quadratic if we can't factor it? Quadratic formula can work great. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula. So we need to know what our b value is. That's the 4. So negative 4 plus or minus the square root of b squared, so that's 16, minus 4, a, which is 5, c, which is negative 7, all over 2 times a. If you can't factor it to solve it, it doesn't mean it doesn't cross the x-axis. That's what we're looking for. Where does it cross the x-axis? We can use another method called the quadratic formula. This is 16. Here we have 2 negatives, so it's actually plus. That's where a lot of people make a mistake. It's not minus, but it's plus 140. 20 times 7 is 140. So 16 plus 140 over 10. So that's negative 4 plus or minus 156 over 10. So we're going to take our negative 4 plus the square root of 156 and divide that by 10. We get this answer of 0.8489. And if you wanted to, you could also do negative 4 minus the square root of 156 divided by 10. And you get this silly number called negative 0.6469. Negative 1.6489, I guess. Right? But of course, we're not interested in negative number of items. So this says 0.8489. That's not even one item. Why did we get a decimal like that? Oh, these are the number of items, and the number of items are represented by thousands. So we're going to take our 0.4898 times it by 1,000, and that gives us 800 or 8.9. So about 849 items. Oh, sorry, you can't read all that. There it is. So that's the other way to get to $14,000 in product. Well, how else could we do that? You said we could look at a calculator. Yes, we did. So if we look at our calculator, in y equals, if we type in negative 5x cubed plus 6x squared plus 15x, that's our equation. And we want to know, when does this equal 14? And we hit graph. And we can see the graph get plugged in here. But what we don't see is the 14 because our grid only goes up to 10. So we need to make our window a little bit bigger. So we're going to go to window and we're going to make the y value bigger than 14. Make it any number bigger than 14. I'll make it 20. While I'm here, I might as well change up my y value so we can stretch this graph out a little bit. So this kind of swings it out a little bit more, a little easier to see. And there we have it. If we look in our table, we can see that when x is 2, we get 14. But if we're less than 1, we actually get close to 14 also. Less than 1 is 14. So where exactly less than 1? So if we do second trace, which is the calculate, we go to intersection. and we need to take the intersection of our two graphs. This is our first curve, our second curve, enter, and then you get close to the answer you're looking for. If you come over here to this one, you can actually get the 2 to show up. It'll tell you that it was 2 items. And if we go through that first curve, second curve thing again, and guess, and we guess over here, it will give us our 0.8489. And that's what we had gotten earlier. So you can use, at least you can use your calculator as support to be sure it's doing what you want it to do, if your answers made sense. All right, any questions? Last one. Go ahead, take a look at that, pause the video, work through that, think about how you could set it up, and then come on back, we'll talk you through it. So for this next one, we have a prism, which is very similar to our first question. Our prism has a square base, and it has a height that has sides longer than, actually 5 longer than, the sides of the base. So something like that. So we have x for the sides of our base, and our height is 5 more than the sides of the base. This is a rectangular prism, so we know the volume equals length times width times height. So 28 is going to equal x times x times x plus 5. So 28 is going to equal x squared times x plus 5. So we get an x cubed plus 5x squared, and that all equals 28. We multiplied it together, just like before. Now what we're trying to figure out is what the height of our prism is going to be. Before, when we solved this one, like with number 1, we could use factor by grouping. And factor by grouping worked. But if you look at this problem, it's actually minus. Subtract that 28 across. We don't have 4 terms like we did in the first question. We only have 3 terms. But this is not a trinomial that we can use a quadratic formula, because this is not a quadratic. This is a cubic. So a quadratic formula doesn't work here because this isn't quadratic. It's cubic. The only way of factoring that we did this was factor by grouping. It won't work. So what's our other option? Factoring, we can't use the quadratic way to factor, just 2 parentheses and go through it, because this isn't a quadratic format. Guess and check is always a possibility, but nothing that's going to give you much support in 11th grade math. So no, I'm not going to say guess and check is the way to go. So what we're going to look at are possible zeros. What does that mean to you? Possible zeros. We're looking at the possible zeros that go into 28. What are the factors of 28 divided by 1? Well, we don't have to worry about the 1. So what are the factors of 28? 1's a factor, 2's a factor, 4 goes into 28, 7, 14, and 28 are all factors of 28. So those are all your reasonable numbers to try to see which one's going to work. So you asked about guess and check. So essentially, this is your appropriate guess and check. You could try 1, but you're going to find out that 1 cubed and 1 times 5, that's a total of 6. That's nowhere close to 28. So 1 doesn't work. No need to use a negative because negatives can't be dimensions of your box. 2 would be 8, and 4 times 5, that's 20, and 8, and 28. 2 looks like it's kind of working. Two seems like a pretty good deal. We've got 1, 5, and don't forget the 0 for the x's. And negative 28. So you bring down your 1, you multiply, you get 7, you multiply, you get 14, you multiply, and it's actually a positive 28. And that's what we suspected. We found a 0. So x minus 2 is a factor. So you might want to look at x squared plus 7x plus 14. That's not factorable. Okay, and the discriminant at b squared minus 4ac, b squared minus 4 times a times c, that gives us a negative 7. The discriminant is negative 7. What does that tell us about the quadratic formula? That tells us that if we use the quadratic formula, we'd get a negative 7 under the square root. And if you take the square root of a negative, you get an imaginary answer, and that means that there's no real solutions using that quadratic. So we're done. There is only one answer, and we're not surprised by that. It was 2. So the height of the prism, x plus 5, 2 plus 5 is going to be 7. That would be 7 feet. So if you can't use factor by grouping, you can factor it apart using synthetic division. You look for your numbers that go into your C value, your last value here. Your constant is the best term to use, divided by your leading coefficient. And that's just 1. So what goes into 28? And that's it. The discriminant, remember, is b squared minus 4ac. And that's the part of the quadratic formula that is underneath the radical. And if that discriminant was a positive number, then we would have had two possible answers coming out of this quadratic. If we would have had a 0 as this discriminant, we would have had one possible 0. We had a negative out of this quadratic, which means no possible zeros. So that's why we eliminated any more possible calculations from the quadratic. So we could take a look at the calculator. Clear the calculator out. So when we go here, we're going to plug in our x cubed and our 5x squared and our negative 28. Right? And if we go ahead and graph that out, it's going to do this wiggliness. We can drop way down if we want, so we can see farther down the line. You'll see that the graph is doing all this wiggling down here, but it only crosses up at one spot. It only has one solution. That's what the discriminant was trying to tell us. The other possible answers are not real answers. It seems like there's answers available, but those answers don't really exist. So there was only one answer, and our table shows us that we get our 0 when x is 2, and that's what we said it was. So of course, calculators, if you know what you're doing, can get you to some answers quicker. But this is the algebraic that you need to make the next step.